Welcome back to another lesson in MCV4U. Today we'll be looking at the quotient rule. And so similar to the product rule, which we looked at previously, the quotient rule can be used to determine the derivative of a function that is the quotient of two other functions. So again, as it says in the name, the quotient means that there's a division between two functions here. So for a rational function in the form of h of x is equal to f of x over g of x, we can determine its derivative by using a simplified rule. So we look at the quotient rule here. Again, in the form h of x is equal to f of x over g of x. So if it looks like this, and g of x is not equal to 0, we see here that h prime of x will be equal to f prime of x times g of x minus g prime of x and f of x. So if you recall, when we looked at the product rule, it looked very similar to this. However, when we looked at the product rule, instead of it being subtracting, we added. So there's a difference there. And then also, we're going to divide this entire thing by g squared of x. So the top is similar to the product rule, but there's, again, it is subtraction, and the bottom is divided by g squared of x. Again, if we want to write it here, or if u and v are functions of x, then d over dx, u over v, is equal to du over dxv minus u dv over dx over v squared. So again, here, notice the similarity of the numerator with the product rule, but the operation is subtraction. Therefore, again, the order matters on what we do here. So there's the proof there if you want to take a look at that. So again, here, example number 1 says determine the derivative of h of x is equal to 4x minus 3 over x squared plus 1. So again, like we did with the product rule, we'll label one of these terms as f, and we'll label another of these terms as g. So this we'll put as f of x, and x squared plus 5 we'll do as g of x. So here, if we write h prime is equal to f prime of g, or f prime times g times f prime minus f times g prime over g squared. Okay, so here we have h prime of x is equal to, first we do f prime of x, so 4x minus 3, the derivative of that is 4, g of x, which is x squared plus 5, minus f minus g prime of x, which is going to be 2x, and f of x, which is 4x minus 3. At the bottom, we got g squared x, which is x squared plus 5, and this entire thing squared. So here we can expand it. We'll get 4x squared. So we'll distribute everything in. So here we'll have 4x squared plus 20. Remember that negative 2x multiplies into each of these components. So it's negative 8x squared plus 6x. And that's all over x squared plus 5 squared. Here, if we collect our like terms, here, simplifies to negative 4 x squared plus 6x plus 20 divided by x squared plus 5 squared. Here, if we simplify, we can factor out a -2. We'll be left with 2x squared minus 3x minus 10 over over x squared plus 5 squared. And so here we see that our derivative of this function will be -2 bracket 2x squared minus 3x minus 10 over x squared plus 5 squared. And again, 2x squared minus 3x minus 10 does not factor into two values, so we can just keep that there. You would have to use the quadratic formula, which doesn't help us simplify this particular equation. Okay, so again, always try to simplify first, again, before taking the derivative of the function. So here, if we look at this question, it says determine the derivative in simplified factor form of y is equal to x squared minus 1 over x cubed plus 1. So first thing we'll do, we'll try to simplify here. So again, y prime is equal to, so let's label this again, the first one as f of x. We'll label the one as g of x. So y prime is equal to 2x. Again, the derivative of x squared minus 1 is 2x. G of x, x cubed plus 1 minus 3x squared, x squared minus 1 over g of x squared. Okay, so here, first thing we can do is we can factor out a common factor of x to give us y prime is equal to x, square brackets, 2x cubed plus 1 minus 3x, x, 3x squared, or sorry, 3x, x squared minus 1 all over x cubed plus 1 squared. Here we can expand inside the brackets. So y prime is equal to x bracket x cubed. So we have 2x cubed plus 2 minus 3x cubed plus 3x over x cubed plus 1 squared. And so let's collect our like terms here. So we have y prime is equal to x negative x cubed plus 3x plus 2 all over x cubed plus 1 squared. Here we can factor out the negative from the values inside the bracket. So here we have y prime is equal to negative x cubed minus 3x minus 2 over x cubed plus 1 squared. So here, if we simplify this, of x cubed plus 1 being, so we simplify the top and we simplify the bottom. So here we'll have negative x plus 1 squared, and x minus 2 over x plus 1 squared and x squared minus x plus 1 squared. Okay, and if we look at this over here, so again, x cubed minus 3x minus 2, we can factor that out to be equal to x plus 1 x squared minus x minus 2, and then we can simplify the x squared minus x minus 2, so that'd be x plus 1 x minus 2 x plus 1, and so we can rewrite that as x plus 1 squared x minus 2. So that's how we factored out the x cubed minus 3x minus 2, and that's what's in the numerator there, along with the negative x that was multiplied on the outside. And here, if when we have our x cubed plus 1, it simplifies to be equal to x plus 1 x squared minus x plus 1. And so here we get x cubed plus 1, which is equal to x plus 1 x squared minus x plus 1. Again, but here it is x cubed plus 1 squared. So then we have x plus 1 squared and x squared minus x plus 1 squared as well. So here, the x plus 1 squares will cancel out. And here we'll be left with negative x minus 2 over x squared minus x plus 1 squared. Okay, so let's continue on. So example 3 here says, determine the equation of the tangent to the function f of x is equal to x squared minus 3x over x to the power 4 minus 16 at x is equal to 0. So if you recall, we have to find the equation y is equal to mx plus b, which is the equation of the tangent, or equation of a line. And this is when the slope is equal to f of x, and we know that x is equal to 0. So here we have f prime of x is equal to f of x again over g of x. So the derivative of x squared minus 3x is 2x minus 3. And then g of x is x to the power 4 minus 16 minus here the derivative of g of x, which would be 4x cubed, and f of x, which is x squared minus 3x. And this is all over g of x squared, x to the power 4 minus 16 squared. And so here in this situation, because we know that x is equal to 0, we do not need to simplify the derivative. So do not need to simplify derivative. Rather, we can just sub it into the equation. So 2x, that's going to be, so x is equal to 0, so that's going to be 0. This is going to be equal to 0. This entire term is going to be equal to 0. This is equal to 0, and this is equal to 0 as well. Bottom, sub that in, that will be equal to 0. So here we're left with f prime 0 is equal to negative 3, which is from this little term, and we also have our negative 16 here as well. So negative 3 times negative 16 over negative 16 squared. We can cancel one of the negative 16s. And we have f prime of 0 is equal to negative 3 over negative 16, which is equal to 3 over 16, which is the slope of our equation. So now we can sub that back in. So here we need to find the y value when x is equal to 0. So, so y value when x is equal to 0. We'll sub that into the original equation. So here we have f of 0 is equal to 0 squared minus 3 times 0 over 0 to the power 4 minus 16. So here we have 0 over negative 16, which is equal to 0, 0. So our point that we can sub in is 0, 0. And we'll sub that back into our equation of y is equal to mx plus b. Then we found that our slope was equal to 3 over 16, so x plus b. And we'll sub this point into the equation. Therefore, we have 0 is equal to 3 over 16 times 0 plus b. Therefore, b is equal to 0. So our equation of the tangent to this particular function will therefore be equal to y is equal to 3 over 16x. Okay, so let's look at this last question here. It says, determine the coordinates of each point on the graph of g of x is equal to x squared over 2x plus 1, where the tangent is horizontal. So the tangent is horizontal means that the slope of the tangent is 0. So the slope of the tangent is 0. So here, if we have g of x is equal to x squared over 2x plus 1, and here we see that g prime of x will be equal to 0, because that is the slope that represents the slope, and the slope is equal to 0 because the slope of the tangent is horizontal. So here, if we derive this, so the f prime of x, which is 2x, g of x, 2x plus 1, minus g prime of x, which is just 2, and f of x, which is x squared. That's all over dx plus 2x plus 1 squared, and that all is equal to 0. And here, we can write it as 0 over 1, and we can simply cross multiply here. And so here, we're left with 2x, 2x plus 1 minus 2x squared is equal to 0. Expand that, we have 4x squared plus 2x minus 2x squared is equal to 0. Combine the like terms, we'll have 2x squared plus 2x is equal to 0. And if we factor out a common factor of 2x, we'll be left with x plus 1 is equal to 0. And so we have two answers here. Again, x is equal to 0, or x is equal to -1. So then to find the corresponding, so here, when we see the corresponding y values, here we're going to sub it in into the original equation. So again, g of 0 is equal to 0 over 2 times 0 plus 1. And so when x is equal to 0, y is also equal to 0. And then we'll sub it in for g -1 is equal to -1 squared over 2 times -1 plus 1, which is equal to -1. And so therefore, the 2 points are at 0, 0, and -1 and -1.